Hello, Cloud Gurus, and welcome to the course, Deploying and Managing a Web Application in Kubernetes with Terraform. My name is Jesse Hoke, and I'm the training architect who will be guiding you on your learning journey. During my time in the industry, I've had the privilege of working in various roles as a systems administrator, engineer, SRE, database administrator, and even dabbled a little bit in management. I like having fun with technology, and I hope to share that with you. In this course, we will use Terraform to deploy a Kubernetes cluster and then deploy a HTML5 web application that allows you to play Pac-Man in your browser. We start off by talking about why you should use Terraform with Kubernetes and go over some of the tools you will need to get started. We will then go through some demos of provisioning an AKS, EKS, and GKE cluster with Terraform. Next, we'll go over the Terraform code that will deploy our Pac-Man browser-based game, and then apply that code to deploy our web application with Terraform. We'll be playing Pac-Man in no time. So by the end of this course, you'll be able to deploy a Kubernetes cluster in Azure, AWS, and GCP in a matter of minutes. You'll also be able to deploy all the Kubernetes resources necessary to run an HTML5 application with a Node.js frontend and a MongoDB backend. Now, you'll need some experience with setting up a Kubernetes cluster, as well as deploying and managing Kubernetes resources. You'll need to understand some infrastructure as code concepts, as well as have some experience using Terraform. And of course, having some experience managing and creating resources in Azure, AWS, or GCP doesn't hurt. Now, I don't know about you, but I am ready to get cracking at getting this Kubernetes web app created so we can play some Pac-Man. Welcome to Deploying and Managing a Web Application in Kubernetes with Terraform. Catch you guys in the next lesson.
Hey there, gurus. Welcome to the lesson. In this lesson, we're going to go over how to provision a Kubernetes cluster with Terraform. In this lesson, we're going to go over some reasons why you might want to use Terraform with Kubernetes. We are then going to go over the options that we're going to use and demo in this course. We're also going to go over the prerequisites that you would need installed to deploy your Kubernetes cluster. So why use Terraform with Kubernetes? Now, while you could use the built-in provisioning process for each type of cluster we're going to go over, Terraform provides you with these key benefits. First, it gives you a unified workflow. So if you are already deploying infrastructure to the cloud with Terraform, your Kubernetes cluster can fit in your workflow, and you can also deploy applications into your cluster using Terraform, which is also something we will be demonstrating later on in the course. It also gives you full lifecycle management. So Terraform doesn't only create resources, it also is used to update resources and delete tracked resources without requiring you to inspect the API to identify those resources. And it also gives you a graph of relationships. So Terraform understands dependency relationships between resources. Say, for instance, if you're using an EKS cluster, it knows it needs a specific VPC and subnet configuration. Terraform won't attempt to create the cluster if the VPC and subnets failed to create with the proper configuration, which will save you some work in the long run if there is an error. So what are your options? So Terraform is great for managing Kubernetes resources locally, but it doesn't really do anything for you when provisioning a local Kubernetes cluster. So in this course, we're going to really just focus on deploying our Kubernetes cluster into the cloud. So we're going to do demos in the big three cloud providers that we offer sandboxes and labs for. So first up, we have an AKS cluster in Azure. We can easily provision this with Terraform. An EKS cluster in AWS, and then also a GKE cluster in GCP. All three of these clusters we will provision in Terraform in our upcoming demos. Now, when provisioning our Kubernetes clusters in our cloud providers, we need to have a few things installed and configured before we can provision our resources. First up, we need an account in one of our cloud providers, whether that be Azure, AWS, or GCP, or all three. We then need the cloud CLI that corresponds with each provider. For example, Azure CLI, AWS CLI, or Google Cloud SDK. We'll also need kubectl installed and configured with our cluster's context. And then finally, we need Terraform installed. This next part is just a suggestion. To simplify things a little bit, we're going to install using two popular package managers. First up, we have Homebrew, which can be installed on Mac OS or Linux. And then we have Chocolatey for Windows. Now, for those using Linux, yes, you can use the already included package manager, but you may get differences in version depending on what's stable. Whereas with Homebrew, you'll get the most up-to-date versions. Now, Homebrew pretty much installs the Flatpak, so you could just install the Flatpaks of each one of these. But for consistency, we're going to use Homebrew. So to install each one of these package managers, it's pretty simple and straightforward. For Homebrew, on Mac OS or Linux, you'll simply run this command. This command is essentially curling the Homebrew GitHub repo and pulling down the install script. And then to install Chocolatey on Windows, you're going to run this very long command down here in PowerShell. A quick note, with PowerShell, you must ensure that the Git execution policy is not restricted. It needs to be set to bypass or all signed instead. If not, the Chocolatey install will fail. So with the package managers out of the way, if we want to install what we need to provision our AKS cluster in Azure, on Mac OS or Linux, we'll first install the Azure CLI. So we'll do a brew install Azure-CLI. You can then also install kubectl by doing a brew install Kubernetes-CLI. Once those are installed, you can then use the Azure CLI to do an AZ login to log into your Azure instance. Now in our upcoming demos, we're going to be doing this on our sandboxes that we provide. For those using Windows, you'll first install the Azure CLI. Pretty similar. You'll just do a Choco install Azure CLI. Same with kubectl. Instead of brew, you're going to do Choco. And then you'll use that same AZ login once your Azure CLI has been installed to log into Azure. Now to install this to provision an EKS cluster, very similar as you can imagine. For Mac OS or Linux, you'll install the AWS CLI by doing a brew install AWS-CLI. Install kubectl, brew install Kubernetes-CLI. And then to log into your AWS instance, you'll then do an AWS configure. For those using Windows, pretty much the same thing, except you're going to use Choco instead of brew. You'll install the AWS CLI, and then you'll install kubectl by installing the Kubernetes-CLI. You'll use the same AWS configure to then configure your AWS CLI to use your AWS instance. Now for GKE, it's a little different. We just have one extra step here. So on Mac OS and Linux, you're going to use brew to install the Google Cloud SDK cask. This is similar to, say, on Yum when you use groups to install a group of packages. And then for kubectl, you'll install the Kubernetes-CLI. You'll then log into GCP using the gcloud init command. And then to add your account to the ADC in GCP, you'll then run the gcloud auth application-default login command. So just one extra step there. Very similar for Windows. To install the Cloud SDK, you'll do a Choco install Cloud SDK. kubectl, you're going to use the Choco install Kubernetes-CLI. You'll use that same gcloud init command to log into GCP. Then you'll use the add your account to ADC the same way as you would with the Mac or Linux install. So to sum up the lesson, we went over the 3 reasons to use Terraform with Kubernetes. It gives you a unified workflow, as well as full lifecycle management and a graph of relationships. We went over what needs to be installed and configured when using Terraform with Kubernetes. So we know we need an account with our cloud provider. We need to install the CLI associated with our cloud provider. We need to have kubectl installed, as well as configured to use our cluster. And we'll need Terraform installed. And then finally, we went over how to install and configure those tools for use with each one of our cloud providers, which in our demo will be Azure, AWS, and GCP. Up next, we're going to be jumping into our first demo, how to provision an AKS cluster with Terraform. Thank you guys for joining me, and I'll catch you in the demo. Hey there, gurus. Welcome to the lesson. In this lesson, we're going to demo how to provision an AKS cluster with Terraform. I'm going to show you how to take a little bit of Terraform code and within a matter of minutes, have a fully functional AKS cluster up and running and ready to go. First thing in this demo, there are a few prerequisites that you'll need before jumping in. We went over these prerequisites in the last lesson, and I am not going to show you this in the demo, but you will need to have your Azure account set up. Easiest way to do this is using our Azure Sandbox. You'll also need Azure CLI installed and configured. And what I mean by configured, you need to run the AZ login command and get yourself logged in. You'll need kubectl installed because we will be using it to interact with our cluster. And then you'll also need to have Terraform installed. Now, if you are doing this in the Cloud Shell within Azure, Terraform is already installed and you won't have anything to worry about there. But if you're doing this on your machine or created a VM or whatnot, you'll need to have Terraform installed as well. So basically in this demo, we're going to provision an AKS cluster with Terraform. We're going to go ahead and go over the Terraform code piece by piece and explain which resource each resource block within the code represents, as well as modifying the code to add information like our service principal information as well as our resource group information. And then we will go through the deployment process with Terraform to successfully apply our code and deploy our cluster. Now, a quick preview of the Terraform code we'll be using. We'll be working with 5 files. Now, our Terraform config files consist of our aks-cluster.tf file. This is where the main AKS cluster configuration will be. We have a variables.tf file. This will have a couple variables that we're going to use to create our cluster. We have our terraform.tf vars file, which is where we're going to put in our service principal information, which will then be called by our variables.tf file. We'll have an outputs.tf file, which will create our outputs in our terminal after our apply has finished, as well as the ability to call those outputs later when necessary. And then finally, our versions.tf file. This is where we're going to set the version for our provider and our required version of Terraform. So with that said, we're going to jump over to VS Code, and I will go ahead and start running through the demo. So here we are in VS Code. In my demos, I'm going to go ahead and be using VS Code, so this way we can see the code that we're running. Now, this can easily be just done in a terminal and using other editors like Vim or whatnot. But I figured this is the best way that I can demonstrate it for you guys so you can see the code and the commands that we're running. So I'm in a folder called AKS on my machine. I'll do a quick ls here down in the terminal. Here are the Terraform config files that we talked about in the previous slide. Up above here, we have our version.tf file, which I'm going to start there. In this Terraform configuration file, we are declaring our provider we're using, which is the Azure RM provider from HashiCorp. We're providing the version number here. And then we're also providing the required version down here for Terraform. So we're requiring version 0.14 or higher. Next, we have our AKS cluster.tf. In this file, let me just move this down so we can see a little bit more here. We start off with our provider configuration block here. Normally, all you would need is the provider and Azure RM, and then the features with our squiggly brackets here. Since we're using our Azure Sandbox, we have this line here that says skip provider registration equals true. The reason you need this for the sandbox is because the restrictions that we have in our sandbox will not allow for the provider registration check to run, and you'll get an error, so that's why we add this. Next, we have our resource group block, where we're declaring our resource group. Another restriction that we have in our sandbox is that you cannot create a resource group. There is one already provided. So we're going to go ahead and import our resource group before we apply. So this way we can use our resource group information and manage our resources all with Terraform. We're going to have to pull that information from Azure. So we're going to have to set our resource group name and our resource group location here. Also in our resource group block, we're setting a tag here for our environment, which we're calling demo. In our next resource block, we have the Azure Kubernetes cluster resource that we're going to create. The name of our Kubernetes cluster we're setting here. We're going to name it Guru-AKS. Here we're pulling in our resource group location and our resource group name from our resource group block up here. We're setting our DNS prefix. We're calling that Guru K8s. Here we're defining our default node pool. Our node pool is going to be called Guru. Our node count will be 2. Our VM size, we're using a standard B2S. And our OS disk size, we're setting to 30 gigabits. Here we're pulling in our service principal information from our variables file. So we're pulling in the app ID and the app password from our variables. Next, we're enabling our role-based access control. And then we're adding another tag for our AKS cluster under that demo environment. Our next Terraform config file is the terraform.tf vars file. Here we're going to set our app ID and our password. This is going to feed into our variables file. Here we're pulling in the variables app ID and the variable password for our service principal. And then finally, our outputs.tf file. We have 2 outputs that will be generated after our configuration has been applied. Our first one, we're going to pull in the resource group name. And our second output is going to display our Kubernetes cluster name. So the first thing we want to do is we want to edit our Terraform TF vars file and add our app ID and password from our service principal, which is provided for us on our sandbox page. So we just need to copy and paste it from there. So I'm going to copy my application ID and get rid of what's in between the quotes here and paste that ID here. I'm going to do the same thing for the password, which is actually the secret. We'll do the same and get rid of what's in quotes and paste that here. And we're going to save this. Now, if you were doing this on your own and not in the Azure Sandbox, you could run this command to create your service principal. This will display your app ID information as well as your secret. After we've done that, we can come down here to our terminal and we can go ahead and initialize our Terraform workspace. What this will do is it'll pull down all of our provider plugins to use with Azure to deploy our Kubernetes cluster by doing a Terraform init. As you can see here, it is pulling in our provider plugins. We get all this green here. Let us know that we have successfully initialized our Terraform working directory. As you can see here, if we did an ls-la, you can see a .terraform directory was created. This is what stores all your provider plugins. Anytime you would add a new provider to your configuration, you will have to rerun this Terraform init to pull all that information in. So now the next thing we want to do is we want to import our resource group into Terraform state. So this way we can manage our resource group and use our resource group throughout the rest of our configuration. To pull this information, we can simply do an AZ group list. Here you can see the name of our resource group. We're going to grab that. We're going to come up here to our resource group resource block. We're going to get rid of what's in quotes for the name and paste our resource group there. Next, we're going to come here to location and grab our location. We'll come back up to our resource block. Get rid of everything that's in quotes here and paste that there. And we're going to go ahead and save our file. And now we want to come up here to the ID, which is this /subscriptions/subscription ID /resource groups /resource group name. We're going to grab everything there that's in between the quotes and copy it. And now to import our resource group into our Terraform state, we'll do a Terraform import and do Azure RM _resource _group dot, and then the resource group name, which is Guru, space, and then paste our ID here and hit enter. Give this a minute to import our resource. Here we get two green messages here. We get import prepared and then import successful. So now we've successfully imported our resource group and we added the information up here to our resource group resource block. We're now ready to deploy our cluster. So first, to confirm that our syntax is correct, we can do a Terraform validate. We get a green success. And now we can go ahead and apply our configuration. So we'll do a Terraform apply. Before I hit the apply, we're going to go ahead and make our terminal larger here. Now we can review what the apply is going to do here. See all the things that it's adding to Azure. Looks like it's doing everything we intend it to do. So now we just type in yes to confirm the changes that we want to make. And we'll give it a minute here to apply our configuration and deploy our AKS cluster. Now this process should take between 5 to 10 minutes, so don't be alarmed if it takes a little bit. And there we go, we successfully applied our configuration. You can see here we have our outputs, Kubernetes cluster name, which is Guru AKS, and our resource group name. Next, we need to configure kubectl to use our cluster. So this way we can interact with it. We're going to actually use our outputs here in this next command. Go ahead and paste this command here since it's pretty long. We're going to do an AZ AKS get credentials. And then we're going to do a -- resource group, which is going to pull our resource group from our Terraform output. So we're going to run the Terraform output command -raw, and then we're going to pull in the resource group name. Then we're going to do a -- name, and then we're going to use that Terraform output command again and pull in our Kubernetes cluster name. Go ahead and hit enter. You normally wouldn't get this message, but because I've practiced this a few times before I've done this, I already had kubectl configured with my Kubernetes cluster name. I'm just going to say overwrite. And to test this out, we can do a kubectl get all, which will show us our current Kubernetes cluster resources, which we have our Kubernetes service. And then if we want to pull up our Kubernetes dashboard, we can run this command Here we're doing an AZ AKS browse, and then we're doing -- resource group. And then we're using the Terraform output command to pull in our resource group name. And then we're using the -- name and using that Terraform output command to pull in our Kubernetes cluster name. If we go ahead and hit enter, it will open up our browser and bring us directly to our Kubernetes dashboard, which we'll hop on over to right now. Here you can see our cluster. We have our metric server here, our connectivity agent, our core DNS autoscaler, and our core DNS nodes. As you can see, we have 2 of each, except for our core DNS autoscaler. If you remember, we set the node pool count to 2, so it deployed 2 nodes for each one. And now we successfully have our AKS cluster up and running. So to review, when provisioning an AKS cluster with Terraform, we reviewed the Terraform code that we used to deploy our AKS cluster. We made some modifications and changes to our code, and then imported our existing resource group into our Terraform state. And then we used Terraform to successfully deploy and provision our AKS cluster. So that'll do it for this demo. Thank you guys for joining me. Up next, we're going to go over pretty much the same process when we demo how to provision an EKS cluster with Terraform. See you there. Hey there, gurus. Welcome to the lesson. In this lesson, we're going to demo how to provision an EKS cluster with Terraform. So we're going to take a little bit of Terraform code and deploy an EKS cluster into AWS in a matter of about 10 minutes or so. So first, there's a few prerequisites that you'll need to have accomplished before you start creating and applying your Terraform code to create your EKS cluster. First, you need your AWS account. To make it easy, you can use our AWS sandbox. Next, you'll need the AWS CLI installed and configured. So it's using your AWS access key. You'll need kubectl installed, and you'll need Terraform installed. When provisioning our EKS cluster with Terraform, in this demo, first we will go over the Terraform code that we're going to use to deploy our EKS cluster. Then we're going to go through the deployment process using Terraform to provision our cluster. Now, the Terraform code we're going to use. First, we're going to have a terraform.tf file. This sets the Terraform version and our provider version. We're going to have a variables.tf file, which contains our region variable and controls where to create the EKS cluster. We're going to have a vpc.tf file. This provisions a VPC, subnets, and availability zones using the AWS VPC module. Next, we have an outputs.tf file. This defines the output values for our configuration. And then we have our EKS-cluster.tf file. This uses the AWS EKS module to provision an EKS cluster and other required resources. This includes our autoscaling groups, our security groups, our IAM roles, and our IAM policies. And then we have our main.tf file, which configures our providers as well as creates a data set and a local variable. So with that said, why don't we hop over to VS Code and get started with our demo. Here we are in VS Code. Up top, I have our Terraform files that we're going to be working with. And down here, we have our terminal. I'm in a directory called EKS, which will serve as our Terraform working directory. If I do an ls, you can see the files that we're working with up here in our editor. If we take a look at our terraform.tf file, you can see we are setting our required providers. So first, we're setting our AWS provider. We're using the random provider, which will allow us to generate random values. We're using the TLS provider, the cloud init provider, and then down here, our Kubernetes provider. At the very end of our file, we have a required version of Terraform that we'll use. And we're going to use Terraform 1.3 or higher. Next, we have our main.tf file. Here we're setting our provider configurations, as well as creating a local variable using a data set that we're creating here. So first up, we are configuring our Kubernetes provider. Next, we're supplying the region, which we're setting using a variable. We're creating our data set for our availability zones. And then we're creating a local variable here for our cluster name, which is also using a random string. In our resource block here, we're declaring the values that we want to use to generate our random string. Next, we have our vpc.tf file. Here we're using the VPC module to create our VPC along with our private subnets and our public subnets. We're enabling our NAT gateway, our single NAT gateway, and enabling DNS host names. We're setting public subnet tags. Here we're pulling in our local variable that's using our random value generator. And then our private subnet tags we're creating in our next block over here. Our next file is the eks-cluster.tf file. Here we're using the EKS module to create our EKS cluster. We're supplying the cluster name via our local variable that we're setting in our main.tf file. We're setting our cluster version to 1.24. We're declaring our VPC ID, which we're pulling from our VPC module. We're declaring our subnet IDs, which we're also pulling from the VPC module. We're allowing cluster endpoint public access by declaring this true. Here we're declaring our EKS managed node group defaults. We're setting our AMI type here. We're configuring our managed node groups in our next block, setting the instance types and our minimal, maximum, and desired sizes. And for our second node group, we're doing the same. Next, we have our variables.tf file, where we're declaring a variable for our region that we're using in our configuration. We're setting it to US East 1. And then finally, our output.tf file, where we're declaring our outputs for our cluster endpoint, our cluster security group ID, our region, and cluster name. These outputs will be generated after our apply. So the first thing we want to do, which I'm going to go ahead and move this up a bit so we can run our code. First thing we want to do is our Terraform init command to initialize our Terraform configuration. This will pull down our provider plugins. You can see we're initializing our provider plugins, pulling down all of our providers. We get the all green, which lets us know that Terraform has been successfully initialized. Next, we can check our syntax to make sure it's correct in our configuration by doing a Terraform validate. We get the green success. So now we'll go ahead and apply our configuration and deploy our EKS cluster. So we'll do a Terraform apply. You can see we're adding all of our resources and information. Looks like it's going to do everything we intend it to do, so we're going to type in yes to confirm, and we'll let it spin. The provisioning of the EKS cluster can take between 10 and 15 minutes, so we'll give it a chance to run. And there we go, our apply has been completed. See, we added 54 resources. We have our outputs down here with our cluster endpoint, our cluster name, our cluster security group, and our region. Now that we've applied our configuration, we now need to configure kubectl. We can do that by using this command here. It's pretty long, so I'm just pasting it here in our terminal. We'll do an AWS EKS, and then we're going to do -- region, and we're going to pull that region into our command via the Terraform output command and telling it to output the region. Then we're going to do an update -cube config, then -- name, and then we're going to use that Terraform output command again to pull in the cluster name. And then finally, since we're using our sandbox, and due to some of the restrictions, we need to use the --no-verify-ssl flag. If we do not use this, it has a hard time retrieving the SSL and will give an error. So we'll go ahead and hit enter. Here you can see that warning because we're using that no verified SSL, but our context has been added to kubectl, so we can now use it to interact with our cluster. So to verify our cluster, we can do a kubectl cluster-info. Here you can see we have our Kubernetes control plane is running, the core DNS is running, so our EKS cluster is up and running. So now if we do a kubectl get nodes, and we can see our 3 nodes that make up our EKS cluster. To summarize, in our demo, provisioning an EKS cluster with Terraform, we reviewed the Terraform code that we used. We went over each Terraform configuration file and what it did. And then we used Terraform to successfully deploy and provision our EKS cluster by using Terraform init command, the Terraform validate command, and then the Terraform apply command. Once that was done, we configured kubectl and were able to interact with our cluster successfully. Well, that does it for this demo. Thank you guys for joining me. Up next, we're going to jump into another demo and we're going to provision a GKE cluster with Terraform. Thanks again and see you guys in the next one. Hey there, gurus. Welcome to the lesson. In this lesson, we're going to demo how to provision a GKE cluster with Terraform. So I'm going to take a little bit of Terraform code and I'm going to provision and deploy a GKE cluster in Google Cloud in just a matter of a few minutes. Now in this demo, there are a few prerequisites. First, you'll need a Google Cloud account. In this demo, I'm going to be using the Google Cloud Sandbox on our site. You'll need the Cloud SDK installed and configured. So you need to do a gcloud init to log in and configure your Cloud SDK. You'll need kubectl installed because we'll need kubectl to communicate with our cluster after we deploy it. And then, of course, we'll need Terraform installed. At the beginning of this demo, when we provision a GKE cluster with Terraform, we're first going to go over the Terraform code that we're going to use to deploy our cluster. And then we will go ahead and deploy our cluster with Terraform, going through the normal steps, first initializing our workspace, validating our code, and then applying our configuration. Now the Terraform config files that we'll be using are, first we have our versions.tf file, which sets the Terraform version, as well as sets the version for the Google provider. We have the gke.tf file. This is the file that will allow us to provision our GKE cluster in a separately managed node pool. Next, we have our outputs.tf file, which will output specific information that we define in this file once our code has been applied. We then have a terraform.tf vars file, which is kind of like a template for the project ID and regions variables. And then finally, we have our vpc.tf file. This will provision a VPC and a subnet. And with that said, without further ado, let's hop on over to VS Code and we will go ahead and start our demo. Here we are in VS Code. Here we go. Up top here, you can see we have all of our Terraform config files that we're going to use. We'll go over each one. We also have a couple of YAML files that we're going to use once our cluster has been deployed. That'll deploy our dashboard as well as set up our admin user in our cluster to be able to view the dashboard. Down here we have our terminal where I can then run the commands, and so you can see the code as well as the commands. If I do an ls down here, you can see the files that we'll be working with. We're in a working directory called GKE. Our first Terraform file that we're going to take a look at here is our versions.tf file. Here in our required providers block, we're setting our Google provider up here. And then we're also defining our required version of Terraform, which is 0.14 or greater. Next, we have our gke.tf configuration file, which is going to do a bulk of the work. At the top, we're declaring a variable for our GKE number of nodes. Next, we're setting our resource here for our GKE cluster. For the name, we're pulling in our project ID and then using that plus the -GKE as our name. We're also pulling in our region for our project here. Now here you can see a note that we can't create a cluster with no node pool defined, but we want to only use separately managed node pools. So here we're creating the smallest possible default node pool and immediately deleting it. And then here's our separately managed node pool that we're actually going to create and keep, which will be our primary node. We're pulling in our location here and our Google Container Cluster primary name. We're also pulling in our node count from our variable up here at the top. Here we're setting our node config, setting a label here with our environment equals and then our project ID. Here we're defining our machine type for our nodes, declaring our disk size for our nodes, and then setting a tag using our project ID -GKE name for our cluster. Next, we have our outputs.tf file. Here we're declaring an output for our region, our project ID, our Kubernetes cluster name, and our Kubernetes cluster host. These outputs should display on our screen in our terminal after our code has been applied. Next, we have our terraform.tf vars file. Here we're going to supply our project ID and our region. Next, we have our vpc.tf file, which we're using our project ID variable and our region variable. That'll be pulling from our Terraform TF vars file. Here we're declaring our provider configuration, and we're setting our project ID and our region here. In our next resource block, we're declaring our VPC. And then finally, in our last resource block, we're declaring our subnet. We'll take a look at the other files when we're getting ready to use them. First thing we need to do before deploying our cluster is we need to modify our terraform.tf vars file. We need to grab our project ID, which we can use the gcloud SDK to pull that information. If we do a gcloud config get-value and then project and hit enter, that'll pull our project ID. So we're going to copy that and we're going to paste it in between the quotes here. I'm going to actually leave my region as US-central1. I'm going to go ahead and save this file. I'm going to make my terminal bigger here. Now to deploy our GKE cluster, we'll first need to initialize our working directory. So we'll do a terraform init. And we get the all green. Our working directory has been successfully initialized. Next, we want to double check that our syntax is correct. So we'll do a terraform validate. Configuration is valid. So now the only thing left to do is to go ahead and apply our configuration. But before we do, it's one thing that I almost forgot. We need to enable both the Compute Engine API and the Kubernetes Engine API in Google Cloud, or we'll get an error in our apply. We can simply do a gcloud services enable. We'll start with the Compute Engine. Do compute.googleapis.com. And since we didn't get a message back, it means that it's already been enabled. So now let's do the same thing for the Kubernetes one. This is going to be container.googleapis.com. We get the operation finished successfully message. So now that we've done that, now we can do our Terraform apply. You can see we're adding all of our resources and information for our cluster. We're going to go ahead and type in yes to confirm that we want to apply our configuration. And we're off to deploying our GKE cluster. Now, this process should take around about 10 to 15 minutes, so sit back, relax, and we'll be back when it's done. All right, our apply has completed. You can see we got the green apply complete message. We've added 4 resources. Here are our outputs that we specified in our outputs.tf file. We have our region, our project ID, our Kubernetes cluster name, and our Kubernetes cluster host IP address. So the next step after our cluster has been successfully deployed is to configure kubectl. Now, what I've found is that the GKE Kubernetes service is slower to come up than, say, our AKS or EKS clusters from previous demos. So more than likely, this command will probably give us a warning, but I'll do it anyway just so you can see that warning. It's a longer command, so I'm going to go ahead and copy it and paste it into my terminal. So to configure our kubectl cluster, we'll run the command gcloud container clusters get-credentials, and then we're going to grab our Kubernetes cluster name from our Terraform output by using the Terraform output command, and then doing a -raw and then specifying the output we want to pull. Then we're going to do a -- region and then supply the region using that Terraform output command again. If we go ahead and hit enter, you can see we get a warning saying the cluster is not running. Now you'll get this because your Kubernetes cluster is still initializing and updating. If we go into our Google Cloud console, I can show you the status of our cluster. Here we are in our console. We come over here to our Kubernetes engine and go to clusters. You can see our cluster is here, but our status is still saying the cluster is being updated. So we'll give this a few minutes to give us the status that it's up and ready to go, and we'll continue. All right, our cluster is finally done updating and is up. You can see we have our little green check here. Let's hop back over to VS Code and go ahead and configure kubectl. We're going to go ahead and run that same command. And there we go. Our kubeconfig has been generated for kubectl. So now if we did like a kubectl get all, you can see our services. We do a -a, you can see all of our cluster. So to test out our cluster even further, we can deploy and access the Kubernetes dashboard. We can do that by applying our Kubernetes dashboard.yaml file. Here in this file, we have everything here to deploy our dashboard, all the services necessary. So if we do kubectl apply -f, we'll do the Kubernetes dashboard.yaml. We'll hit enter. Don't worry about these warnings. It just means the spec in there is being deprecated. So now that that's open, we can then run the kubectl proxy command. I'm actually going to do that in another terminal window. We'll hit enter. That starts our proxy. We go back over to our browser. We should be able to get to our Kubernetes dashboard by using this address. To now access the dashboard, we're going to have to create a token. Select this and enter our token here. So we first need to go back to our terminal. We're going to create the admin user for the dashboard. We're going to use this file here, which creates a service account for our admin user for the dashboard. So we're basically going to do that kubectl apply command again, except this time we're going to do -admin.rbac.yaml. Go ahead and hit enter. We've now created our service account. So now we can go ahead and create our token that we'll use with the dashboard. We'll go ahead and paste that here. We're going to do a kubectl-n for namespace. We're going to point it at the Kubernetes-dashboard namespace. We're going to do create token, and then we're going to create that token for the admin user. We'll go ahead and hit enter. And there is our token. We're going to copy it. We're going to hop back over to our browser. And we're going to paste our token here. Hit enter. And here we are in our cluster. We have our cluster nodes. We have our namespaces. There's our dashboard. Here we have all of our nodes. And we have successfully deployed our GKE cluster in Google Cloud with Terraform. So to summarize, we provisioned a GKE cluster with Terraform. We first reviewed the Terraform code that we used. We took a look at our vpc.tf file, our gke.tf file, our terraform.tf file, our version.tf file, and our outputs.tf file. We then added our project ID in our terraform.tf file. And then once we did that, we used Terraform to successfully deploy and provision our GKE cluster by taking our code, initializing our working directory, validating our code, and then applying our code with Terraform. Well, that does it for this demo. Thank you guys for joining me. Hope to see you in the next lesson, where we'll be covering how to create a Kubernetes web application using Terraform. Thank you guys, and see you in the next lesson. Hey there, gurus. Welcome to the lesson. In this lesson, we're going to go over our Kubernetes web application that we're going to demo in the next few lessons. So in this lesson, first we're going to talk a little bit about the project and what inspired my demos. We'll next go over the components that make up this web application, and then we'll go over the file structure and Terraform files that we're going to be using in the upcoming demos. The project is based off of the example Kubernetes web application created by Ivan Font. Now I've taken the YAML configuration and converted it over to Terraform configuration language for our demos for this project. It is a Kubernetes application that hosts an HTML5 playable Pac-Man game. So at the end of this demo, we'll be playing Pac-Man in our browser. How cool is that? And this game is made up of three things. First, the Docker image. Now I've created a Docker image with the application that our Terraform files will be pulling into Kubernetes. It's also made up of a web server, so our front end, and then our back end database for our live stats and progress and achievements. Now, the two big components that we will be deploying to our Kubernetes cluster are first our web server and then our database. So our front end and our back end. So our front end consists of a web server running Node.js, which will serve up our Node.js application that we're deploying via our Docker image into Kubernetes. And then our backend, which is our MongoDB database and service, which will allow our front end to connect and store information like time it took, how far our progress is, our points that we've scored, so on and so forth. And then our front end will then display that information in real time. So before we start our demo, first off, we're going to be running this demo in an EKS cluster in AWS. So that cluster needs to be deployed and up and ready. We'll need kubectl installed and configured, so it's pointing to our EKS cluster. And then we'll also need Terraform installed. So the Terraform files that we're going to be used in the file structure of our working directory will look like this. Have our Pac-Man project directory or workspace. This will contain our modules directory, which contains two modules. Our first module is called Mongo, which is our MongoDB module directory. And then we have our Pacman module, which is our Pacman web application module directory. So within Pacman, we first have our Kubernetes.tf file, which is our main Terraform file. And this file will declare what providers we're using. We'll also set our preferred Terraform version, as well as call our modules. So within each module directory, start with Mongo, we'll have first a mongo-sc.tf file, which creates our storage class for our MongoDB database. Next, we have the mongo-pv.tf file, which creates the persistent volume for our database. We then have our mongo-pvc.tf file, which creates the persistent volume claim. We then have the mongo-service.tf file, which creates the service for our backend database. This defines the port that our application will connect to, as well as setting up the load balancer for this service. Then we have our mongo-deployment.tf file, which creates the deployment of our pod that's going to be running our MongoDB backend database. And then we have our variables.tf file, which will declare the variable for the namespace, which we'll define in our Kubernetes.tf file. And then for our Pacman module, first we have the Pacman-service.tf file, which creates the service for our web application. It sets the port that we will be connecting to for our web application, as well as sets the load balancer for the service. And then we have the pacman-deployment.tf file, which creates our deployment for our web application. This is where it'll pull in our Docker image that we will be deploying on our Pacman pods. And then finally, we have our variables.tf file, which, just like the one for our MongoDB module, it declares the variable for the namespace, which we'll be providing in our main configuration file. So to summarize this lesson, first, we went over our Pacman web application project. We went over things like the components of the Pacman web application. We went over the 3 components that make it up. We have the Docker image, we have our web server, and then our database backend. We went over that our web server would be running Node.js and that our backend database is powered by MongoDB. For those following along, needs to be set up before we jump in the demos. And then finally, we went over the file structure and the Terraform files that will be used in the upcoming demos. So with all that said, up next, we're going to jump into the Create a Kubernetes web application demo. Thank you guys for joining me, and I'll catch you in the demo. Hey there, gurus. Welcome to the demo. In this demo, we're going to create a Kubernetes web application using Terraform. Now, if you've noticed throughout the course, there's kind of a theme going on here. You can guess it by this arcade cabinet here on the screen. The application that we're going to be deploying to Kubernetes will host an HTML5 Pacman game with Node.js as the web server and a backend to read and write data to a MongoDB database. So you're going to have a fully playable Pacman game within your browser. So in this demo, there are a few prerequisites. Before you get started, you want to make sure you have a Kubernetes cluster up and running. In my example in this demo, we're going to be using an EKS cluster. You're going to need kubectl installed and configured, so it needs to be pointed at the right context so it communicates with your cluster. And then, of course, you need Terraform installed. We're going to provision the Pacman web application. First, we'll take a look at the Terraform code that we're going to use to deploy our Node.js web server, as well as our MongoDB backend database. We'll then use Terraform and apply those configuration files to deploy our web application to our Kubernetes cluster. So now let's take a look at the Terraform code that we'll be using. The Terraform code structure is as follows. First, we have our main configuration, which is going to be pacman.tf. This file has all of our basic Terraform information in it, as well as calling our modules. Our first module will deploy our MongoDB backend database. It's comprised of the mongo-sc Terraform file, which configures our storage class. Next, we have the mongo-pv Terraform file, which will provision our persistent volume. Then we have our mongo-pvc.tf file, which will provision the persistent volume claim. Next, we have the mongo-service.tf file. This will provision our MongoDB service, which will set up a load balance service and set up our ports for our database. And then we have our mongo-deployment.tf file, which is our node deployment of our MongoDB instance. And then we have a variables.tf file, where we'll pass the namespace of our Pacman web application. And then our next module is our Pacman module. This contains the pacman-service.tf file, which creates our web application service, which will give us our endpoint to connect to our game. And then our pacman deployment.tf file, which will be our web server running Node.js. So without further ado, let's hop on over to VS Code and start our demo. Here we are in VS Code. I have my Terraform code up here, and we have our terminal down here where we're going to be running our code. First, let's go ahead and go over what we have. We're currently in our working directory called Pacman. Within this directory, we have our Pacman main configuration file, as well as our modules. If we do an ls on the modules, you can see we have two there, one called Mongo, one called Pacman. Within Mongo, we have 6 Terraform files, which we have right up here. Then we look in Pacman, we have 3 more for our Node.js front end, which we have right here. So first, let's go ahead and go over our MongoDB backend configuration. We'll start off by taking a look at the mongo-sc.tf file. In this file, we're creating our storage class for our MongoDB database. Actually make this smaller so we can see more. Here you can see we're using AWS EBS. Our storage class is GP2. Next, we have our mongo-pv.tf file. This creates our persistent volume. See in our top resource block here, we're creating our persistent volume, calling it MongoPV. We're setting the capacity here to 10 gigabits. We're setting the access mode to read write once. We're setting the reclaim policy here. We're pointing it at our mongo-sc storage class that we created in our mongo-sc.tf configuration. And then we're setting the host path. This is the path to where it's going to mount our volume on our nodes. Next, we have our mongo-pvc.tf file. This is going to create our persistent volume claim. We're doing that here in our first resource block. We're calling our volume claim Mongo storage. Here you can see we're using our variable to set our namespace. And down here, we're setting our spec. We're going to use 8 gigabits of that 10 gigabits of storage. And at the bottom here, we're pointing it at our Mongo-sc storage class name. In our next file, the mongo-service.tf file, we're creating our Kubernetes service called Mongo. Here we're pulling in our namespace from our variable. Down here, we're setting our spec. We're setting the port and the target port for 27017, which is the port to connect to our database. Then we're setting our type here to load balancer. Then for our next Terraform configuration file, the mongo-deployment.tf file, here in our first resource block, we are creating our deployment Mongo. We're pulling in our namespace again from our variable. In our spec, we're creating one replica, so we're deploying one node. We're adding our selector here. Here we're setting our spec. Our volume is going to be called MongoDB. pointing it at our persistent volume claim, which is Mongo storage. Creating our container here called Mongo. Here we're pointing it at port 27017. And here we're setting our volume mount for our MongoDB. And then in our final configuration file, we have our variables file. Here we're declaring our variable for the Kubernetes namespace. You can see that we are leaving this variable empty. This will allow us to pass the variable in our main Terraform file to our modules. Next, for our pacman module, first up we have our pacman-service.tf file. Here we're creating our pacman Kubernetes service, pulling in our namespace from our variable. In our spec, we're setting the port to port 80, and the target port is going to be 8080. So the service is going to be running on 8080, but it will be serving at 280. And down here, we're setting our type to load balancer. Our next file is our pacman-deployment.tf file. Here we're creating our deployment for our pacman nodes, pulling our namespace from our variable. Here in the spec, we're setting the replicas to 1. So we're just going to run one node. Down here in our container spec, we're pulling in the Docker image for our pacman Node.js application. And here we're serving it up on container port 8080. And then finally, our variables file, which has our Kubernetes namespace. And once again, our variable is empty. So if we take a look at our main Terraform configuration file called pacman.tf, here we're setting our required providers, which we're using the Kubernetes provider. For our provider configuration, we're setting our config path for kubectl. In our first resource block here, we're creating our Kubernetes namespace, which we're calling pacman. Here we're calling our first module, our MongoDB module here. We're setting the source. We're pointing it at our MongoDB module directory called Mongo. And here we're passing the Kubernetes namespace, pacman, to the variables file in our MongoDB module directory. And then finally, we're calling our pacman module. For our source, we're pointing it at our pacman module directory. We're passing our Kubernetes namespace again to our variables file in our pacman module directory. And we're doing a depends on, and we're saying it depends on the creation of our MongoDB module up here. So now that we've gone through the files, let's go ahead and deploy our web application using Terraform. First, we'll do a Terraform init to pull down our provider plugins and our module information. We'll get the all green. We'll do a Terraform validate to validate our configuration to make sure our syntax is all good. We get the green success. Now the last thing to do is to deploy our web application by applying our configuration with Terraform apply. Go ahead and make our terminal window here a little bit bigger. Go ahead and hit enter. Type in yes to confirm. And we'll give this just a minute to deploy our resources. We get the all green message saying our apply has completed. See down here, we've added 8 resources. If we do a kubectl, we'll do a -n for namespace and use the pacman namespace, get all. You can see we've successfully deployed our pacman web app to our cluster. Here at the top, you can see our pods created from our deployment. We have our MongoDB pod, and we have our pacman web application pod. We have our services here, our Mongo service and our pacman service. We have our 2 deployments here, and we have our replica sets. Everything's in a available and ready state. And to access our Pac-Man web application, we can grab the external IP from our Pac-Man service, copy that, and then go over to our browser and play some Pac-Man. And there we go. Our Pac-Man game is ready to play. Go ahead and click. You can see it is a fully functional game. I'm currently playing it poorly. So to summarize this demo, for one, that was really cool. 2, creating Kubernetes web application, we first reviewed the Terraform code. We then used Terraform to successfully deploy the Kubernetes Pac-Man web application to our EKS cluster. So we just took all that code, and within a matter of seconds, we had a fully functional Pac-Man game in our browser. I mean, how cool is that? So up next, we're going to jump into another demo where we're going to manage resources for a Kubernetes web application. We're going to take the same web application and we're basically going to add some more nodes to the cluster to support higher traffic. Thank you guys for joining me, and I'll catch you in the next demo. Hey there, gurus. Welcome to the demo. In this demo, we're going to manage our resources for our Kubernetes web application. First, there's obviously some prerequisites for this demo. They're pretty much the same as our last demo. You need to have your Kubernetes cluster up and running. We're using EKS in this demo. You need kubectl installed and configured with the context of your cluster, so you can use kubectl to communicate with it. And you need Terraform installed. And to add one more to that list, you need your Pac-Man web application deployed. Now in this demo, we're going to scale the Pac-Man web application. First, we're going to take a look at the Terraform code we need to change to scale it up and down. And then we will apply our changes and scale our web application up, and then make changes to our code again, and then apply them to scale it back down. So let's go ahead and hop over to VS Code, and we'll go ahead and jump into this demo. Here we are. As you can see, our web application is up and running. We have one node apiece running our front end and back end. If we wanted to say add 3 pods to our front end and 2 pods to our back end to support our application, we can make those changes in the deployment configuration files. So first, let's go ahead and give ourselves a little room here. If we come over here to our Mongo deployment.tf file, we scroll down here to the spec, you can see we have a replicas equals 1. If we wanted to add a node to our database, we can change that. We're going to do 2. We're going to go ahead and save our file. Then we're going to come over here to the pacman deployment.tf file. Scroll down here to the spec and change the replicas here. We're going to scale our front end up to 3 nodes, and we'll go ahead and save our file. So now we can come down here to our terminal, and we can go ahead and apply our changes. So if we do a Terraform apply, see here we have 2 resources to change. Type in yes to confirm, and we'll let our apply run. We get the all green. Go ahead and clear my screen here. Now if we do a kubectl -n pacman and then get all, you can now see we have 2 MongoDB pods running. We have 3 Pac-Man pods running. A replica sets here, 3 desired, 3 current for our Pac-Man nodes with 3 ready, as well as 2 desired MongoDB nodes, 2 current and 2 ready. If we jump back over to our browser, we refresh the page, you can see we still have a fully functional Pac-Man game. And now if we wanted to scale it back down, come back here in our Pac-Man deployment, change that back to 1, save our file, come back to our Mongo deployment.tf file, change the replicas from 2 to 1, and save our file, and then do another Terraform apply. See, we're changing to again. Type in yes to confirm. We get our apply completed. If we do another kubectl get all in our Pacman namespace, you can see our replica sets back down to 1 desired, 1 current for both our MongoDB and our Pacman web app. And you can see we only have 1 pod running for each. So we successfully scaled our web application back down. Double check, we'll go back over here to our web browser to make sure that our game is still up and running. And there we go. This will never get old. This game is a classic. So to summarize this demo, we were able to manage a Kubernetes web application. We modified our Terraform code, specifically our deployment.tf configuration code. We looked for that replicas argument, and we changed the value to scale both our MongoDB backend as well as our Pacman web application front end, which allowed us to scale up the Pacman web application using Terraform. We then went back in and changed those values back, saved our configuration, and then applied it to scale our Pacman web application back down to 1 node apiece. So that does it for this demo. Thank you guys for joining me. I hope you had fun playing around with Kubernetes and Terraform and playing a little Pacman. Up next, we're going to hop into the course wrap-up. We'll do a quick summary of the whole course, and we'll go over some possible next steps in your learning journey. Thank you guys again, and I'll catch you in the next lesson.
Well, gurus, you did it. You successfully completed the deploying and managing a web application in Kubernetes with Terraform course, where we deployed a web-based game of Pacman with real-time stats. So you might be thinking, where do I go from here? There are a few different paths you can take on your learning journey. The first path, if you are more interested in Terraform, we have quite a few courses that will show you how to provision and manage resources in Azure, AWS, and GCP. A good short course to get you started is the Creating a Terraform Configuration for Multi-Cloud Use. Now, if you're interested in getting certified in Terraform, you can prepare by taking our HashiCorp Certified Terraform Associate course. And for our next path, if you are leaning more towards the Kubernetes side of things, we have some really great content. We can get you prepared for the CKA, CKAD, and CKS. Here are a few courses that may be a good place to start. First, starting off, you can take the Kubernetes Essential course, then maybe dive deeper with Kubernetes the hard way, and then you might be ready to tackle the Certified Kubernetes Administrator course and then get certified. Finally, we'd love to know how you did with this course. So feel free to reach out to us on Discord or our forums. It has been an absolute honor being your guide on this learning journey. Keep being awesome gurus and learn all the things. Until next time.